And number 18, in the figure above, BD is parallel to AE was the length of CE. Okay, so this question is a similar triangle question. So what we have here, the smaller triangle on the inside, okay, is similar compared to the big triangle on the outside. So remember, similar triangle, they have the same shape, right, but not necessarily the same size. So we could have one that's bigger, the other one smaller. We know they're similar because DB and AE are parallel lines. So in geometry, you can prove these two angles will be called corresponding angles. That have parallel line, those angles will be the same. Same thing here, about 90 degrees, this will be the same. And this angle is shared by both triangles, right? So they'll be the same. So all three angles are the same. Then they're similar. Okay, but on the SAT, you don't have to prove them similar. Okay, so for a question like this, you have one triangle inside another, and if they look the same, you can pretty much assume there are similar triangles. Okay, otherwise you can't really solve this question. Okay, so what we can do to make things easier, let me just redraw the small triangle over here. Okay, let me just go and redraw this. So this is CDB, and this is 8 and 6. We're comparing that with the big triangle on the outside, this triangle here. And for the big triangle, the only side that we know here is this side on the right. AE is 18. Okay, so for similar triangles, what happens, the corresponding sides should have the same ratio. Okay, so to solve for any missing sides, we can always set up a proportion. Okay, so the 18 and the 6, they go together. So they're both the side on the right. And then we're trying to solve for CE. Okay, so CE is the whole thing, the hypotenuse for the bigger triangle, right? So this is the longest side. So that's X. So X should go with which side? It should go with CD, right? Because CD is the longest side for the small triangle. So they should go together. But the problem here is that we also don't know what CD is. Okay, so I had to figure that out first. So we could solve for CD because we have the smaller triangle as a right triangle, and we know the two legs is 6 and 8. So for right triangles, we can always do the Pythagorean theorem. So for any right triangle, we can do this formula: a squared plus b squared equals c squared. And the two legs, that would be a and b. So it'd be 6 squared plus a squared equal to c squared. And to solve for c, that would be 6 squared would be 36 plus a squared is 64 equal to c squared. Well, with 36 plus 64, that should be 100 equal to c squared. And to solve for c, we take the square root on both sides. So c equal to square root 100, which is 10. Okay, so this will be the side here for side CD is actually equal to 10. All right, so now we have everything that we need to set up a proportion. We can say this is 18 and dB here, this is 6, so they go together. You can say 6 over 18. So the smaller number or a bigger number, this should be equal to, on this side, 10 over x. Okay, so 10 is from the smaller triangle, x is from the bigger triangle. And this will be our proportion. To solve for x, we can just go ahead and do cross multiply. Okay, so we can just cross it over diagonally, and the product of each cross should be the same. So we'll do 6 times x is 6x equal to 18 times 10 is 180. And then to solve for x, we can divide by 6 on both sides to get x equal to 180 over 6. What's 180 over 6? That's equal to 30. Okay, so x is equal to 30. And that will be our final answer for question 18.